Today, we're gonna find out how iPhone batteries are made from start to finish. I'm here at the Pinsun Battery Factory in Shenzhen, China. They make aftermarket replacement batteries for iPhones like this one. They also make tons of other types of batteries. They aren't sponsoring this video, but I'm thankful to them for letting us in on short notice so I can show you how cool it is. First, we're gonna head off to their battery cell supplier in Dongguan, 2 hours from here. Very simply, lithium-ion batteries are made out of 2 sheets of aluminum, a cathode and an anode, coated with 2 different substances. On the positive side, the cathode is lithium cobalt oxide, and on the anode side, the negative side, is graphite. There are 2 identical factory lines here for adding that coating on the aluminum sheet. This is the cathode side, where the lithium is. These giant mixers behind me are mixing the lithium cobalt oxide with a binding agent and a conductive agent. And they're sort of like big stand mixers that you would find in your kitchen for making cookies or bread or cake. Once they're fully mixed, these drums underneath are wheeled over, and then they pump the solution out through this pump here and through this pipe into the next room where they're coating the aluminum sheet. So let's go take a look. So this is that pipe coming from the pump all the way over here to this filter, and this is where it's actually getting coated on the aluminum sheet. So the aluminum sheet starts out on this roll here. This is actually the second time this particular sheet is being coated. They coat both sides, but the first pass looks exactly like this. They just happen to be running this right now. That sheet goes through a series of tensioning rollers underneath this platform, up over here and around this drum where the actual coating is happening. So right here, there's 2 plates where the solution of lithium cobalt is being squirted out very precisely onto the sheet as consistently as they can. The next step is to bake it on with a giant conveyor belt oven. Let's go see that. So through here, we can actually see the anode line. And I misspoke before. I said that both sides were aluminum. This is actually copper. This giant oven runs all the way from this wall, all the way down to that wall, all the way down there. And it has 8 different temperature-controlled sections where it gradually brings that aluminum material up to temperature and then gradually cools it off. And it ends on the other side of that wall. Let's go see. Whew, it is hot in there. The next step is inspection. There's a lot of inspection in making high quality batteries. This is an X-ray inspector that inspects for a perfectly even coating on the backing material. And it's got an X-ray head that's moving back and forth across the panels as they go through. And finally, it goes over here and gets wound on this drum. Next, we want to make this cathode layer as thin as possible. This is an 800-ton rolling press that has 2 rollers that smash the cathode and the cathode coating as thin as possible. It's shut down right now. They're waiting on further up the line to reload a roll. But this would normally be feeding through the press here, then through a thickness gauge, and again onto a roll where it's going to go upstairs, and we'll put together the actual battery cells. Let's go see that. All right, next we're going to the cleaner parts of the factory. We got to go through an air shower and then switch clothes. That just knocks off all the dust. So this is the anode slicing workshop. And this machine here takes a full roll of material. This is the anode side, but cathode, I imagine, is pretty similar. Takes the full width roll that we saw downstairs and slices it into thinner rolls that are the right width to make a battery. The other thing that's going on here is CCD inspection, AKA visual inspection with a camera, checking the top and bottom just for any visually obvious imperfections in the coating layer that might be a problem. And it'll actually stick a sticker on here that will be cut out to mark a bad section that will be cut out later in the process. Let's head into the process that I have been most wanting to see, which is where they actually take this and turn it into a battery cell. Now it's time to change into a full coverall for the next part, which is supposed to be very clean. We've got Mr. Zhang here from the factory with us, and then Tony, who's been translating for me. Yeah, okay, so we gotta take this all the way off. All right, let's do that. We'll be back in a minute. Ta-da! I wanna show you one thing real quick before we go to the next step. That's as far as I can bend over because this part is too short. Let's go. Oh, wow. Okay, this is easily the coolest machine I have ever seen in any factory. This is where the magic happens. Okay, so it's gonna take me a while to figure all this out. It looks like we've got the anode material down here, that copper colored material. And then the cathode material is over here. And there's a whole bunch of tensioning going on. But the magic is happening right here. This is where the two layers are coming together with an insulator in between and are being wrapped up into that jelly roll, right? This is a spiral of two materials sandwiched together, the insulator in the middle, and then somewhere down the line, we're injecting that electrolyte. Let's see if we can get Mr. Zhang in here to explain some more of the details. So Mr. Zhang, I want to understand a little bit more. It seems like the heart of the operation is right here, where we're wrapping the cathode there and the anode over there and the insulation material here into that jelly roll sandwich. But there is a ton of machinery on both sides. Can you explain a little bit about why this is so complex?
它这个复杂的机器，如果是靠人来去做的话，就是人每次他要去，往放几片，现在全部是机器来去做。然后呢，这个卷完之后，它是这里面检查是自动检查它的对齐度的，这个地方会检查自动对齐度。再来就是我卷扰的这个一致性，是通过这个它里面的张力每一个都在检测。还有一个就是这个极片会经过很多道出尘。它会有毛刷一直在扫，就是在这个在轴的转的过程中会不断的出尘。
And then what is the green stuff here? It looks like tape.
这个是在这个上面贴的绝缘胶。哦，绝缘胶。如果这个机器它就可以自动贴绝缘胶， OK， 保证它不短路。
And is that the section in between two pieces of tape? That's the length of one battery, one cell. So like from here to here is one cell.
不是，它是一个基耳跟基耳之间是一个，就是上面这个基耳和另外一个基耳之间是一个。Yes.
So not very long, only about that long.
Yes. 有一小电池。
Okay.
你看，我们每一个都有一个基耳，就是负极的基耳，一个基耳代表一个电池。
I noticed there's a tons of blue stuff in here. Is that the same thing we've been walking on the ground?
这个是在粘尘。就是我们这个空气中还是有一点点粉尘，我粘住它，不让它乱跑，避免它进到那个产品中去。
I got it. And there is just layers of this blue tape all throughout this machine trying to capture dust. I'm beginning to think that dust is very important to keep this as clean as possible. Everywhere we go, it's all about dust, 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 no dust. So this is where the battery tabs are being cut and attached. This is the roll of battery tabs here, and then it's a metal strip that's feeding in here. And then this is the cutter. There, it cuts it off, and then it's coming over here and sticking it on to the anode, the negative side, right there. That is super cool. So this is the tape that Mr. Zhang was talking about. And it looks like it's got two spools, one for the top and bottom, and it's sticking on one at a time. Check this out. There goes. There's one piece. Stick it. Second piece. Stick it. There's the top. Here's the bottom. It's sucking the tape upside down to a vacuum head. Can you hear this in my microphone? Wait for it. That's really cool.
So this part mainly packaging, like packing all those the cells, okay, into this aluminum.
So putting the outside on.
Yeah.
The outside layer.
Outside layer.
So that looks like what's happening over here. That's right here is where we put it into the packaging. What is the outside made out of?
Aluminum.
Aluminum. Okay. So an aluminum package on the aluminum package on the outside, and heat sealed.
Yeah, heat sealed. Yeah.
Okay. So we got the rolls here of the anode and cathode and the insulation material. Put those in the outer package here with this really complex line that's basically just creating a vacuum pack, right? A sandwich, and heat sealing it. And then down here is where we're putting in the electrolyte.
Yeah, injection, yeah. Electrolyte will be injected.
And that's right here, right? That's the electrolyte right there.
That's right.
And then the box at the back is the vacuum.
Yeah.
Yeah, and that's sucking out all the air and excess gas and whatnot. Let's look at the finished product down here. Can we pick one of these up? I need gloves. Okay. This factory line is amazing. I've not seen anything quite this automated before. It is impressive. It also sings songs, I'm assuming for various air conditions. But I want to show every last little pulley, but we're gonna have to show it at a little bit higher level. Okay, so this is now starting to look like a battery cell. So this is the cell here, right? And this will be cut off.
Yep.
And what are these two lumps here?
Oh, this is the air bubble.
Oh, okay. So that was all the air that was in here before got pushed into those. I got it. And then of course these are the two battery tabs. These, we'll see later, will be attached to the rest of the electronics on the battery. And then just a little bit of protective plastic here.
Yep, that's the protective layer, yeah.
Okay. And then this whole section will get sliced off later in the process, right?
Yes,
Yeah,
that's right.
okay. All right. I did a little research ahead of time. We walked around earlier off camera. Let's go see what happens next now. We finally got to change out of our bunny suits back in the hallway outside the labs. The batteries next come in here into this warm room. It's 44 degrees Celsius. That's about, I don't know, 110 Fahrenheit, somewhere in there. They sit here for 48 hours and they age before they get charged. Let's go take a look at the charging process. You got to do the first charge while you're physically squeezing the battery. And Mr. Zhang said that this is because if you don't, the battery gets like squishy and floppy. And so you want to press it together so it's nice and firm on that first charge. So here, they've basically got a charging setup that's also a press, that's pressing all the batteries together. And he said that it's really important, this machine in particular is designed so that there's constant pressure on all the batteries so that one isn't firmer than the other. There's a robot arm over here that's loading batteries off a stack. And then this robot here is unloading batteries that are finished charging out of the press. Mr. Zhang said that they charge batteries for 2 hours this first time. They take 2 hours to charge the batteries up to 50%, and that's all they charge them to at this step. The next step is to cut off all this excess material so that it looks like a normal battery. But there's a little bit of complication. These two bubbles here are pockets of gas, carbon dioxide. And we need to puncture those and then suck out all of the excess gas under a vacuum and then heat seal this piece here and then finally trim it off. This is the phase where it's loading the vacuum chambers. There's 3 vacuum chambers here. They puncture holes in those little gas pockets and then heat seal the seam. And then the batteries come down here. And this is the trimming and folding setup. So they trim off that excess and then fold it over. And finally they get repacked again. Now it's time for some serious charging. So the batteries are now at 50% charge, but we got to bring them all the way up to 100% and then discharge them to see what their actual capacity is. So that's what's going on in here. These are a bunch of shelves that all have the batteries hooked up to their own individual clips, positive and negative. The clips are actually kind of special. They have a giant pad in back. That's where the actual charge or discharge current is happening. And then they have a little voltage sense pad up front. And that gives an accurate voltage measurement while they're charging or discharging. So all these are hooked up. This process, they come by and hook these up by hand. This process takes about 7 hours to charge it all the way to 100%, down to 0, and then bring them back up to 50. And that gives a pretty good accuracy of what is the actual capacity of each battery. They have this little data grid, 2-dimensional QR code here. That's for tracking each individual battery through this process. They're starting to accumulate data now about the quality of each battery. Kenneth is off camera talking crap and saying that it's a data matrix, not a data grid, and that it's not a QR code. I'm just gonna call them QR codes from now on. And the last main step is another aging process to just check that the batteries are stable. So the very first thing they do is check the voltage again. They then put them in storage for 5 days. So the first 3 days are high temperature, the second 2 days are normal temperature. And then they check the voltage again down here and do a bunch more inspection. So camera inspection, X-ray inspection, just checking quality, consistency, making sure that everything is as they expect. Next, let's head over to Pinson's factory in Shenzhen to see how they turn these battery cells into fully fledged iPhone batteries. This is a pallet of battery cells. They're all packed into little trays here, but they're not a finished product yet. They're just the battery itself. We need to add a bunch more before they're ready to ship out. The next step is to print on the logo and all of the warning information and labeling and recycling info and things like that, all the labels that go on here. The only thing that was printed on here prior was just this little tiny QR code. They're using a silk screening process with UV curable ink, and that's just so that it dries instantaneously because they want to be able to print on both sides, so they don't want to have to wait for it to dry. So the first step here is the silk screening. They've got their design here on the silk screen, just like a t-shirt silk screen, and the battery's underneath. And then under door number 2, we have the UV lamp, which is curing the UV paint. And in door number 3 is the real surprise. They have a robotic set of pinchers that's flipping it over so they can print the other side. And then back here, this guy's job is QA. So he's checking every single battery on both sides to make sure that the printing is correct and doesn't have any smudges or anything like that. It looks like he could do this in his sleep. The next step is we need to attach the battery management system, the BMS, onto the cell like this. And the battery management system is all kind of the smarts that Pinson develops here. This is the system that protects against over voltage, over current, discharging the battery too much. It's the safety system for the battery. It's also what's called the gas gauge, which is literally what it sounds like. It keeps track of the charge on the battery by watching what goes in and what goes out and what goes in. Let's check this out. This is a super awesome automated line. I asked them if you could buy one of these, and they said no. This is totally custom. They designed it. They had somebody else build it. But wait till you see. The first step is just loading the trays. So we're just loading batteries onto the conveyor belt. In here, this is where we're doing the trimming. So we're flattening, and then they're coming in and cutting, and then they're bending them over. Each stage, as this rotates, does one more thing, one more thing, one more thing. This machine looks like an erector set. It's all, channel stock aluminum. All of these parts are pretty standard for factory machines, and you kind of glue them together in different ways to do whatever you need it to do. Some of the things in here are just ingenious and so simple, yet do something that ends up being super complex. So this is the part where we're actually attaching the BMS onto the battery. And they're using a fiber laser. If you guys haven't seen the fiber laser video we did up in Jinan, go check that out up here. It's pretty darn cool. This is a much smaller one than we showed in that video. Same idea though. We're using a fiber laser to weld the pieces. I think this is steel.
Yeah, one is aluminum, and the other I'm not sure what is.
Not sure the name. Can we translate?
I don't know what is. Let me find. I don't even know in Chinese.
Okay. Nickel.
Nickel.
Nickel. Okay, I know nickel. Yeah.
Oh, you know. Okay.
So one side is aluminum, one side is nickel.
Yeah. Yeah.
So soldering is out of the question here. We cannot solder this.
No,
you
so
must weld it.
You must use. Yes.
You must weld it. Okay, got it. All right. So nickel and aluminum, and that's why we got to laser them. So the battery management systems come from a tray over there. Batteries are coming in from over here. We're lasering each one, putting them in a jig, and then lasering each one to join them together, and then flipping them over onto a conveyor belt to the next step. So Mr. Young, I wanted to ask you, I saw that you have a little box of sand here with some tongs and a bucket of water with some scoops. And I wanted to ask you, what are all these for?
是这个电池呢，是如果发现短路，设备装机短路了，那我们就直接就灭火，就直接用这个钳子夹在水里面直接灭掉。哦。消防栓也是这样。
So this is if a battery catches fire and you need to put it out.
Yes.
I got it. Yeah. So you have long tongs to reach into the machine to get it and put it out. Yeah, got it. How often does that happen?
可能有时候一天呢会出现2、3次这种情况。
Oh, so that could happen like twice a day.
Twice a day?
Yeah, that could happen.
Oh my God, that sounds exciting.
Yeah.
Yeah.
I don't want to happen. But
Right, no, I understand.
That's
I wouldn't want it to happen on my machine either.
Yeah.
So the next step, now that the BMS is attached, is bending it into the right orientation. And that's what this machine does. It's at least what's happening here. Mr. Young, this machine here, what does that do? I can't see if it doesn't look like it's doing anything.
这个机器呢主要是成型，就是弯子这个。
Right, but that's what this is doing. What about that one?
这个呢，因为我们其他有一个气缸配件呢，你现在还在更换中，还是在维修中。
哦，所以那个还没起作用。
对，起完作用我们还贴上这个查受绝缘的啊。
哦，这个是贴绝缘的。
对。
OK。
这个受不了就贴到 绝缘。
Yeah. So this is for installation, this part. But at the moment, because they have a part, they have to be installed. So at the moment they can.
Oh, it's just broken.
Yeah.
It's broken. Yeah. Okay.
So that part, the function is to insulate.
So they've got
put
women
the
doing it by
insulation
hand
on.
right now.
Yep.
Yeah. Okay. I got it. Oh, I see. Okay. So here, he's adding more complex bends to the cable where it plugs into the iPhone. There's some extra crimps. So these here are totally flat, and he's adding all the necessary bends on this so that it fits into the iPhone in the right orientation. And then they're just putting tape to insulate, is that right?
Yes.
Yeah.
There is another half menu, like an auto machine.
Yeah.
So they put it here, there, and then they bring
Oh,
it
and that's
over.
just putting this
Yeah.
yellow caps on.
Yeah,
I
they-
see. So there's some tape and stickers being put on
On the
the
other
machine
side,
over
yeah.
here.
Yep.
Okay. So we've got stickers going on here. And then we got another turntable. Let's figure out what this turntable does. So batteries are coming in over here, getting loaded by this one. And then tape being put around, folded down, being put on the conveyor belt back over there. And she is checking that everyone is correct and fixing them if they're not, one by one. This one is not working today, is that right?
这个今天不开吗？
今天不开。
Oh yeah.
But this is normally the machine that checks to see if there's any like liquid leaking from the
这个
battery.
这个机器
Okay.
yes. That's right.
They told me this earlier off camera. Okay, so let's go ahead and we'll go to the next step. So some of the steps are being worked around with people right now. Batteries are coming up the line here.
Yep.
Then you guys told me earlier, my understanding is that the batteries now sit for 72 hours, is that right?
对吧？
对，老化
Why are they sitting?
Yeah.
啊，一个
去检验什么的。
主要是呢，放那边呢，主要是放一个钩子，钩子完之后呢，它会出现一种，就看有没有一些漏液呀、或者电芯鼓包这种情况。
Yep.
Oh, to see if any liquid comes out.
Comes out leaking.
Okay,
yeah.
so to
And
see
then-
if it's been punctured, like there's a hole in
That's
it?
right. That's right. And then also, it's checking the internal resistance,
Right.
whether there's a bad quality ones that have a high resistance, so they have to throw it out.
Okay. So they sit for 72 hours in a storeroom,
Yep.
and then they come out here for testing, right?
对，
Let's go look at that next. I just want to add as an aside, we came through earlier with some of the higher managers, and I got kind of an overview of the process. So I'm not explaining this to Mr. Young. He totally knows what's going on. I'm just making sure that my memory is correct, so I'm not saying the wrong stuff. Okay, so we're testing voltage and impedance, just basic battery testing. So these machines here, these testing machines, are these machines that Pinson made or from someone else? Third party. Yeah. And what are they testing? Because he's testing voltage. What are these guys testing?
这边也是测一种解码的解码的，合格之后呢，这个产品就继续包装。如果不合格，我们是要区分出来。
Okay, so we're making sure that the batteries are compatible with an iPhone and that they can be read by the iPhone. Is that right?
Yes.
So the iPhone can talk to the battery management system to see how much charge is there, what is the current flowing, serial numbers, manufacturer information, things like that. There are a lot of people testing here, plugging in one battery at a time. Here we are at the last stage of the process. We've got batteries ready to go to the customer. We got to put them in boxes. So over here, we've got trays, plastic trays that go inside the box. She's adding the battery strips that you need to add them to your phone, putting the batteries in those trays, putting them on the line. And there's a cover piece of plastic that goes on top before it goes into the box. This right here is quite cool. So this is a camera that's taking a picture of the QR code so that they know what battery went into what box. There's a QR code on the outside of the battery, and somewhere down the line here, they're then scanning that and matching the two together. We've got boxes ready to go here. There's the QR code. Each one of these barcodes is unique, so they know they can differentiate every single battery from each other. This machine is literally opening the box. Oh, here's the barcode scanner right here, and then stuffing the battery in. How cool is that? But this beats everything. This is an automatic box closer. It's flipping over the flap on the bottom and tucking it in. Next is my other favorite machine. This is the sticker machine. This is putting those little clear dots of adhesive, of sticker, over the bottom flap to keep it closed. They're on the roll here. They're really hard to see, but there are little circles here. They're being flipped down on here, and then this brush is sweeping down over them to stick the bottom part right here on. Then finally, this is printing the manufacturing date. So there's a little black printing here that just says when it was manufactured, what batch, that kind of thing. And then finally, we go into the shrink wrap machine. And this is just adding the shrink wrap on the outside of the box. I don't know quite why they do this because it's not over the top and bottom flap, but my guess is that it keeps the artwork on the box looking nicer. Finally, we take the little boxes and we put them in medium boxes, and then we put the medium boxes in big boxes. And of course, they're scanning barcodes all along the way so that they know what went where. And finally, we have a finished product ready to put on a shelf. Lastly, I just wanted to quickly show you their testing lab, their quality control facility, where they test new batteries, test quality of batches. And one of the things they do in here is do temperature and humidity testing, just to make sure that the batteries don't do anything scary when they heat them up or there's really high humidity. So this is a humidity and temperature testing chamber. Over here, they're doing real-world device testing. So they're taking those iPhone batteries and they're putting them in an actual iPhone and seeing how long it takes to discharge. So they can accurately say it lasts for 10 hours, it lasts for 12 hours, whatever. The really cool part is that this is a webcam pointed at the battery display here. So they are actually videoing this battery as it decreases, so they know the exact moment that it hits zero. And so they've got an iPhone here, they've got a couple more iPhones here. They had an iPad out earlier when we came through the first time. Super cool. So here, they have a spectrometer for ROS testing, ROHS, which is the environmental standards around what elements can be in whatever product you're producing. The most important one is lead, so lead-free solder, things like that. They're testing various parts that go into the batteries here to make sure they conform to those standards. In here, they have all the really crazy tests. So here, this is a salt mist test. They're spraying salt water all over the battery to make sure that it doesn't short out and blow up. Over here, they have a furnace, a blast furnace. So they are a furnace that controls blasts. So they are cooking the batteries up to 130 degrees Celsius to see if they puff up but don't explode. You know, the biggest concern that consumers have with lipos is, you know, they catch fire, right? The famous, you know, Samsung Note 7 catching fire on airplanes and causing all sorts of problems. This is them testing to make sure that that doesn't happen with their batteries and that they're safe to, you know, within the limits that are reasonably going to happen. It's good to know they're paying attention to it so that we don't have to. That about does it for this time. I'm Scotty from Strange Parts. This is Pinson. I want to thank them for giving me access to their factory. If you want to find out more, click the link down in the description. But for now, make sure you hit that subscribe button so you don't miss more factory tours. I'll see you again soon.